Hello everybody and welcome to my talk about a paper that reports on our study where people were confronted with matching or unmatching multimodal stimuli. My name is Weidner and I am happy to tell you a little bit about this topic. Today's VR is really good. The audiovisual quality of the displays and the rendering allows for a good quality of experience. The other sensors are not that good though. There are a few haptic devices out there, but they are not that widely available and do not deliver the same level of quality. Even more rare than haptic displays are olfactory and gustatory displays. It is relatively hard to work with them and samples are often expensive. And because of that, among other reasons, these displays and the interdependencies in these multimodal displays are underexplored. What we know is that matching cues in multimodal displays can enhance certain properties like sweetness and sourness, and we know that vision guides perception during bimodal incongruency. For example, when participants see and eat something, we can influence perception with additional or altered visual stimuli. However, most experiments only investigated two cues or were focused on modifying rather simple properties like sourness and sweetness. We set out to expand this space by investigating what humans perceive when vision and olfaction match, but gustation is mismatched. That's research question 1. And what humans perceive when vision, olfaction, and gustation don't match. That's research question 2. Our user study for this had the following procedure. First, we did 2 pre-studies to determine our smell and taste samples. Here, important was that the smell samples were easy to identify and that the taste sample, so the food item people were going to eat, had no taste at all. With these samples, we invited participants to our laboratory and let them eat our tasteless food item while experiencing various combinations of olfactory and visual cues. In 4 trials, vision and olfaction displayed the same food. In 12 trials, these two senses displayed a different food. And in 4 trials, we displayed an irritation product to avoid that participants detect any patterns. As a display, we used our Smello spoon. It has a tracking target, a small container for the smell sample, a fan that distributes this smell, and, well, a spoon. With that, participants could eat a tasteless food, smell it, and a VR headset displayed the visual cue. In the center of this slide, you can also see our stimuli. Unfortunately, you can't smell them. That is, for olfaction and vision, we displayed banana, carrot, tomato, and cucumber. However, for gustation, we use a mesh of zucchini, which was cooked but served cold. Please keep in mind, participants always ate this zucchini mesh, but saw and smelled different combinations of banana, carrot, tomato, and cucumber. Okay, so let me show you a few of our results. Looking only at the congruent cases, meaning those trials where vision and olfaction matched, but participants still ate the tasteless food. We first asked participants if what they smell and see is the same and expected that many or most answered with yes. Results were surprising though. Basically, participants guessed if it is the same or not. Thus, the bimodal congruent cues, so vision and olfaction, paired with the mismatched gustatory cue, the zucchini mesh, made it hard for participants to answer this question. The results were not different than chance predicts. Next, still looking at the trials where smell and vision matched but taste didn't, we asked participants to tell us what they just ate. We expected them to follow the matching visual olfactory cues most of the time. However, results are, again, unexpected. Participants mentioned a lot of unrelated food items, here in orange, or mentioned a product that they had experienced in previous trials. You can see those in blue. and few followed the congruent visual olfactory cues, here in green. Overall, the answers were not different than chance predicted. In retrospect, of course, this makes sense as participants did not detect the matching visual olfactory cues as shown in the previous slide. Still, we are confident in our smell and taste samples as they were all elicited through formal pre-studies. Because of that, we assume that other factors threw people off. Some are, for example, the mouthfeel of the food item or a very light and lingering smell and taste of the food item. When we consider only the trials with trimodal incongruency, meaning that taste, vision, and smell did not match, results are also unexpected. Again, we assumed participants would follow vision when identifying the consumed food, based on prior research. However, when we look at the numbers, results are similar to the bimodal congruent case. Participants followed what they saw more or less by chance. In addition to that, they mentioned what they smelled less often than chance predicts. Most often and more often than chance predicted, they mentioned something completely different. Here, the answers showed a wide variety, as was the case in the bimodal congruent trials. Okay, so what did we learn from that? Most important, we learned that three modalities complicate things a lot. If we want to use congruent visual and olfactory cues to enhance or alter a tasteless food item beyond its basic properties like sourness or saltiness, more research is needed as identification seems to be imperfect at best. The reasons for this are manifold. A few worth investigating are the influence of the food's mouthfeel, but also the potential presence of very light lingering taste and the effect of retronasal smelling. If we have trimodal incongruency, our results indicate that the dominance of vision is not prevalent anymore. Again, this requires further investigation on what leads to this. It could be that the difference between the individual stimuli is too large and that this does not align with participants' expectations anymore, which in return hampers perception. This is related to the assimilation contrast theory. A systematic approach investigating if various levels of the stimuli's strength or saliency leads to different or even more promising results seems necessary. Well, this brings me to the future work, which is a lot. Most important, future studies should also include differently flavored food meshes. Remember, we only used zucchini mesh, which was supposed to be a tasteless food item. With that, other combinations can be investigated, such as matching gustation and vision with incongruent olfaction. Our results also motivate investigating if the strength of the stimuli, especially gustation and olfaction, influences the perception in these incongruent situations. It is also worth to investigate if the difference in food texture is a factor. Thus, looking at drinks, soups, solid foods, and so on is another important research avenue. That's all from me. More data and more results are in the paper, including the information on the pre-studies. Thank you for your attention, and I'm happy to answer your questions.